Well, good afternoon, everybody. I'm pleased to have the distinction of not being the person standing between you and lunch, or between you and drinks and dinner. I'm also pleased to be here to talk to you about the security ramifications or implications of kind of the latest new thing in networking, software-defined networks. It was a brief shot of the agenda here. The things we're going to cover. I always like to start off these talks with a little icebreaker. On the way here, I was contemplating sort of how to open this talk, and thinking about the confluence of kind of the next generation of applications and how they're going to be run, and the cloud, and kind of how we're going to run these new agile and dynamic networks. And it struck me that this confluence is either going to be fantastic or maybe not so much. And kind of in the middle of this contemplation, I'm driving, I don't know, about 65 miles an hour down I-96 on the way here. And it's very, very foggy. Otherwise, I'd be driving about 75 miles an hour. And I ran across a confluence that didn't quite work. There was a very shiny, very bright, sparkly, kind of one of these video billboards over on the right-hand side of the road. And as I was looking at that, thinking, wow, that's very distracting, I realized the car that was in the lane in front of me was coming back to me very, very quickly. And I focused back on the road, hard on the brakes, go around, and I'm thinking, why is someone driving 48 miles an hour on an interstate with no lights on a foggy morning? And as I came around the car, the driver looked over at me with this like expression of, this was not how I thought my morning was going to go. He just had this Eeyore, dear God, how to get myself into this sort of expression. And I realized he was driving a Nissan Leaf and on the interstate. So the confluence of a bright, distracting billboard and a battery-powered car that apparently didn't have quite enough juice to accomplish the mission was not a good confluence. So I'm not necessarily going to say that SDN is at that inflection point today. But some things that are fantastic, when separate, are not necessarily great when combined. If I could get a quick raise of hands, if you would feel comfortable standing up here and telling me what you think SDN is, go ahead and raise your hand. Yeah, that's usually about how that sort of thing goes. The best response I ever got to that question, by the way, was the guy in the back who said, well, if we can do this at the bar. And I said, yeah, no, I'm not sure that counts. So sort of in preparation for this, I've had the distinction, the pleasure, of working with a couple of customers who actually have production, SDN-based networks, which is how I got chosen by my colleagues and coworkers to do this talk. I went out and grabbed some sort of standard definitions of what a software-defined network is. And if you sort of boil all these down, you get the notion that what used to be in switches and routers as a combined sort of product or package of a control plane that does these sorts of things, right? We can provision VLANs, we can implement policies, we can have ACLs, filters, we do topology convergences, with protocols like OSPF or spanning tree to sort of determine what the topology of the network should be, programming forwarding entries into the forwarding table of a switch, and then implementing or programming things like rate limiting and class of service. This is all typically contained in one easy to consume package. So if you take a network of today, each of these elements, these routers, the blue boxes, they all sort of think and run and do their thing independently. And that's okay. IP networks designed to be sort of self-healing and routing and route around failed nodes and that sort of thing. But each one of these elements in a network today doesn't normally have necessarily a full or complete scope of what the network really is. So the decisions it can make and the things that it can do with the topology are limited to its scope or its view. Whereas in a software-defined network, we have this abstraction of the control plane out to a separate device that can have a domain-wide policy, have a domain-wide set of forwarding rules, and things like that, that give it essentially a best-case view of the things that you can do in the network. So that is where the, if you will, the promise, kind of the hype of software-defined networks is the ability to drive some intelligence down from a controller or even from applications. You'll hear a lot about, if you run around in SDN circles long enough, you'll hear people talk about northbound APIs. So north, up the stack, up the software stack from the controller would be applications that have some vague notion of what they need from a network, reaching down into the controller and through it to the forwarding elements in the network, the switches and the routers, to decide what the network should do to support that application best. So as I was putting this together, I decided that we should probably talk about some of the other, other things. In the research and education community, which is primarily where I live and breathe and work and have fun, the notion of SDN is tightly coupled to open source. So in some sense, we have two camps, folks that are interested in SDN. One is what I think of as SDN pragmatists, who are looking at software-defined networks as a mechanism for solving interesting problems, unique things that are dynamic. And what I call SDN zealots, who think that everything should go to SDN. Everything should be software-defined, everything should be white box and generic and controlled by a Linux server in the sky. Okay, that's not to say either camp is wrong. I think some of the folks in the research community that are looking at that sort of more purist environment, they're leaning farthest forward out on the edge, where your traditional network operators are really looking at it as a way to solve problems. One of the buzzwords or kind of buzz phrases that I'm familiar with from the vendor side of things is the time to value cycle. So if you kind of poll any organization or group of organizations about how long it takes to get a new application from a concept to a running product that the customer, consumer, whatever can use, some significant portion of that work cycle goes into setting up the network to be able to deliver that new product or service. And the fact that the groups that run applications, develop applications, run servers are not typically the same group that runs switches and routers and networks, and in some cases don't even like to talk to one another. Kind of stretches that out. So kind of this last italicized line that I've heard from, not vendor marketing folks, but actually people that run networks for a living, is that the greatest benefit of SDN presumes that the folks that build applications cooperate with the folks that have to deliver them through the network. And he's laughing because he knows it usually doesn't work that way. I'm a vendor, right? So I come in to organizations and I talk to folks, and I see that, right? It's painfully obvious to me. So I think we're not going to get that full benefit. We're not going to realize the sort of grandest vision of a software-defined network until the folks that build applications and make that functionality are really becoming aligned with the folks that deal with the network. The kind of misnomer that software-defined networks are purely software, obviously that can't be true. We have to have wires, copper wires, fiber optic cables, whatever, and physical switches. Even the most ambitious SDN zealots that I've run across acknowledge that, we still have to have the boxes. They'd prefer that they be very cheap, very sort of low functioning boxes, and that we elevate the more sophisticated functionality into the controller. That's great, but we'll talk about the downsides of that as well. Today, all of the SDN forwarding elements that we showed have to understand the instructions, the protocol, whatever, of the controller. And in some cases, that language is native to that forwarding device, and in some cases, that forwarding device has to have a special agent, or as I like to refer to it, sometimes they have to have a lobotomy of their native control plane and be replaced with an agent that really only answers to the SDN controller. In reality, most SDN networks are hybrid, so they're a mix of controller-based and normal, what we think of as a traditional control plane-based. So the big thing that I got in training many years ago was, so what? Okay, this SDN stuff's cool, there's a lot of hype about it, but why do I care? Why do you care as a security practitioner? Why does it matter? SDN, up until the last couple of years, has essentially been a science experiment. It's been something you'd see at Interop. It's been something you'd see, on a university campus or at sort of a specialized conference like this, but where everybody was interested in SDN. That's changing. Many of the large universities that I work with are at least having the conversation. Where does SDN fit into what I'm doing? Large enterprise customers are at least asking the question, what do I need to do to be positioned to take advantage of this apparent sea change in networking? So probably the most famous SDN implementation to date has been the WAN traffic engineering and data center implementation at Google. So if you wonder where SDN is happening at large scale in real time and you're using it today, that's Google, right? We all know where that is. We all know who those folks are. However, kind of outside of that rarefied environment, we have folks like my friend and colleague who's a network architect at a Big Ten university who says, I would consider OpenFlow, which is kind of the leading contender in the open source SDN world, to really be in the proof of concept phase. And if you look at those specs and the things that you're trying to do in networking compared to the things that they've got done so far in the OpenFlow spec, I'd have to agree he's right. But then if I turn the page and talk to one of my biggest customers, they say, no, OpenFlow is the network. This whole big production environment represented nationwide by all those dots today is a layer 2 network provisioned across the country and run by OpenFlow protocol. And that network today runs dozens of major universities and research institutions, as well as traffic coming from Europe and Canada. And that's happening today. Okay, so that's moving the science experiment out to a large scale where folks are actually running the store. Much like Google, a little bit different scale, a little bit closer to home for some of us, that it's happening now. So as security folks, we will inevitably be asked, how do we know that the SDN-based networks that we're talking about deploying and developing in the future are going to be as secure as the ones that we have now? Okay, we sort of understand in TCP/IP, in layer 2 protocols, MPLS, that sort of thing, how the network's put together and how it's doing what it's doing. Depending on the SDN technology, some of those things are still being written. So what are the best practices? If you go into government regulations like HIPAA and PCI, some of these things are pretty well understood and well documented. What does that look like in an SDN network? How do you take the security policies and audit standards that we're used to using today and apply them to that environment? Okay, where the decision making and the control of the network's now happening separate from the boxes that actually do the physical forwarding and connecting. And then if we take what I've been told is the real promise of SDN, and elevate a level of control up to a set of applications that aren't even in the controller, how do we know what those applications are doing? How do we audit that? Where does that get logged? Who has to answer for that? It's tough. You know, I would assert that a certain number of us in here are going to have to deal with that at some point. We're going to have to answer those questions, or at least figure out how to get those answers. And from a practical standpoint, how do you troubleshoot a network where the control plane is in a box that's completely separate from everything else? Okay, today we can do things like ping, we can look at routing tables, you know, in each device, compare them, that sort of thing. If it's all been abstracted to a controller, we can look at that. But is that necessarily going to tell us everything about what's going on out in the rest of the network? So that's why we care. The science experiment, the hype, all the things that, you know, have been sort of in the pages of Network World or SDN Central or whatever are starting, at least, to come to pass. I've certainly seen it, and as inevitably as Google users, we've used it. So what's the good news for security practitioners? I think at least part of the good news is we can start to solve problems like this without having to do odd routing games, policy-based routing. There's at least a couple of people I know in this room who've had to do interesting things with campus routing, campus networking, switching, to get traffic inspected where it needs to be. I know one customer of mine, personally, who will remain nameless, who spent the better part of a month playing IBGP games, trying to figure out how to get certain traffic that was destined for certain hosts or subnets to go the route of the intrusion prevention system and efficiently route the rest of the traffic down the bypass network. Because in university networks, we don't necessarily inspect everything. Well, in some university networks you do, in some university networks you don't. But in this case, right, we have to comply with regulations when it comes to sensitive systems. So anything that's bound for an HR system, anything that's bound for a store, you know, an online web store or whatever, has to go the inspection route, and everything else kind of runs naked through the network. In an SDN environment, you could, even if you had a dozen of these situations, right? You have one big campus, 10 branch offices. You have to do this sort of thing to all of them. You could go into a central controller and say, I want the traffic to flow like this. Okay, and then that gets provisioned down to the forwarding devices, and it's kind of done. And you don't have this weeks and months long exercise of how to do things. It's an example of that time to value proposition. I know in a lot of IPS implementations, we mirror traffic. So we take traffic, we copy it from its normal path, send it out to the IDS box so it can detect the attacks, tattletale on all the script kiddies that are trying to beat us up. What do we have to do every time we want a different traffic flow for inspection or to add something? We have to go into all the switches, all the routers that get this traffic. We have to set up the mirroring and all that sort of thing. Someday, if the SDN stuff is implemented properly, you could potentially go to a web portal and say, from these hosts to these hosts, boom, I want that traffic replicated, I want it to go out this port. Okay, but that's good, because if you're a security practitioner and your boss wants you to do 20 of these things in a day, it's not you sitting there at the command line like this for hours. It's click, 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 it's done. The troubleshooting aspect is potentially an upside, right? Because today, if I have to look in 5 different boxes to figure out why traffic isn't going where I want it to, a properly implemented SDN system may give me one place, one controller, one maybe cluster of controllers, one set of logs to go look at to troubleshoot all this stuff. Much of what I've seen and learned in SDN implementations, everything's a bit of a double-edged sword, which we'll get to. All the things that are a strength are also potentially the things that can be a weakness. The potentially best news is that were dealing with this stuff at the front end, right? We weren't all here doing this when TCP/IP became the thing, right? This is a legacy. That's a legacy that we have to deal with because it was done pretty much before our time. Okay, SDN is new now, and we'll have the opportunity, if you will, to kind of influence that, to say, hey, you know, it's great that we can dynamically direct traffic, route things, mirror stuff, but what about controls? What about logging? What about auditing? You know, what about separation of duties? Where does all that happen? Okay, and the guy who's sitting there writing the controller code, because he's that guy, can go, okay, well, I'll make sure I put that in there. So what are some things that we can look out for? We'll go back to our SDN drawing, or a kind of high-level SDN diagram here. With all of the control plane functionality extracted out of the forwarding elements, we essentially have a bunch of control channels. So aside from all what we think of as revenue interfaces in the service provider world, interfaces that actually bear traffic that people use, we're going to have some way of letting the controller talk to all the routers and switches. So that's the control plane links. If you peel apart a router or a switch today, that's all in the box. Okay, if you do an SDN implementation inside a data center, that's all in the room. But if you do what my friends at Internet2 did, that's all in the country, right? Their control plane is stretched, in some cases, many states away from the boxes that they're controlling. Well, that's good, and it's kind of scary. As I sort of hinted at before, everything new is a bit of a double-edged sword. Even something as simple as latency between a controller and a forwarding element can be an issue, right? Because if the forwarding element, for example, in OpenFlow gets a new flow, it sends that to the controller and says, hey, what do I do with this? And the controller sends back a response, it goes out that port. Well, what happens if that takes too long? In very dynamic SDN implementations, we could potentially be vulnerable to a denial of service attack, where all we have to do is DOS the control plane port, or end up in a man-in-the-middle situation, where if I get between the forwarding element and the controller, I can read that request as it's headed to the controller, race back with an answer saying, you know, this traffic that's kind of dubious and spurious that I want to get where I want it to go, I'm going to send it down the port where it doesn't get inspected. And then all of a sudden I'm able to do what I want to, and you don't get to see. And kind of the real crux, compromising an entire network is hard when you have to go to each of the network elements and compromise them separately. It starts to become a lot simpler exercise when I can simply go to the web portal on the controller and use somebody's password that I spearphished, and now I'm doing things to the network that you don't want me to. So I'm trying to temper the message. I don't want you to get the idea that I'm an SDN naysayer, right? This is happening, and in some cases it's doing really cool things. But as folks on the security side of things, we need to look at this in such a way that we understand what it really means. Because someday we'll be asked to audit, secure, pen test, whatever, this new architecture. And if you take nothing else out of this talk, aside from please don't drive your battery-powered car on the interstate on a day with bad visibility with flat batteries, particularly while I'm looking at a really glitzy LED billboard on the side of the road, it's that this SDN stuff's going to happen. Nobody really knows on what scale, but the hype alone is going to be enough to propel this considerably into the future. And we need to get ahead of the curve and look at the things that we can do in the way of security mechanisms, processes, procedures, and understanding before it really gets here. I wanted to leave you with some takeaways, some places you can go if you're really interested in sort of the state of SDN and what sorts of things are going on. There's a good book. I happen to know through work association, Tom and Ken, they literally wrote the book, Software Defined Networks. It's an O'Reilly book. There's some obscure animal on the cover like all the O'Reilly books that kind of goes through the various flavors of SDN and kind of the state of things when they got a chance to sit down and write it down. OpenFlow is particularly in research and education circles, because it's open source and because it sort of promises that white box future, is kind of the hot ticket in that environment. So the Open Networking Foundation, openflow.org, and then the nice folks at Network Computing did a good write-up on Google's implementation of OpenFlow on generic hardware. So it not only gives you kind of a good technical overview of what they did, but it also gives some context to why they did that, what problem it solves, that sort of thing. Because if you think very few hands go up when I say, can you explain to me what SDN is, even fewer hands go up when I ask people to explain what's it good for. You know, what benefit does it give me? And the Google folks did a good job of communicating that. I was fortunate enough to hear the fellow that's mentioned in the article speak to an Internet 2 conference live, kind of explaining this fun and adventure that they went through. And at the end, kind of his takeaway, which was particularly relevant to me, was they didn't really want to roll this themselves. They would have preferred that a vendor had sort of built this kind of thing that they could plug their controller into and do their OpenFlow implementation. But at the time they needed to do it, there was no real commercial offering. And with that, as they say, I have come to the end of my prepared remarks. So if you have questions, I'll gladly take them. And if we run out of time, I can kind of take them off to the side here out of band as well. Thank you.